A recursive sequence is a sequence whose next terms require knowledge of the previous terms. The first part of this lesson will be the most difficult. So for the two of you who do not have your notes out yet, you're going to get lost here, okay? What this reads is the nth term is equal to the n minus 1 term plus 3. Or the next term you find by taking the previous term plus 3. That's what a sub n minus 1 means. It means the term that comes before the one you're trying to find. Now, I'll actually write it out, but you need to understand how we're generating these subscripts. I want to find a sub 1. Fortunately, a sub 1 is given to me. It's 0. A sub 2, I now have an n value of 2. So what does this part right here become? A sub 1 plus 3. So that's what I'm trying to now figure out. What is a sub 1 plus 3? Well, what is a sub 1? It's 0. It's the previous term. So now I want to find a sub 3. So what does this become? 2. So I have a sub 2, which is 3. So I get 6. A sub 4, this will become a sub 3. So what is the a sub 3 term? 9. Then a sub 5 is a sub 4 plus 3. It's 12, so on and so forth. You can see the pattern that you're adding 3 to it every time, right? And so is this arithmetic or geometric? Arithmetic, because you're adding something every time. Now, Jill can look at this. She could easily predict the next term, right? What is it? 15. But what is the a sub 120th term? Well, you would want to know what the a sub 119th was, right? Now, the fact is you could figure this out, but you would do so by writing an arithmetic formula. Notice that recursive is not a rule, an explicit rule that determines value. So it has its weakness to it, but it's also kind of fun. We try this one. A sub 1 is what? 1. What? Exactly. So you would multiply it by 3 to get 360, and then minus 3 to get 357. But what you did is you just wrote a rule for it. You see what I'm saying? I'll give you an example where I would challenge you to come up with an explicit rule for it. So you wrote a rule in your head for it, and we could do that. No big deal. A sub 2 is 4 times what? A sub 1 minus 2. Well, what is a sub 1? 1 times 4 is 4 minus 2 is 2. So a sub 3 is 4 times, which is 2. A sub 4 is 4 times, which is 6. A sub 5 is 4 times 22. 84 or 88 minus 2 is 86. Okay? Now again, Braden, you came up with a great idea. You can multiply by this and subtract that to come up with the next number. If I asked you a sub 100, that would take you a bit longer to think through, right? So it's not explicit in that you can plug in 100 and just generate a value. We would have to write that. But look at this one. A sub n minus 1 plus 2n plus 1. Start with a sub 1 is equal to 0. How do I find a sub 2? Zero, because that's a sub 1 plus 2 times, what is n in this problem right now? It's 2. N is 2. I'm finding the second term. A sub 3. 5 plus 2 times 3 plus 1. A sub 4 would be 12 plus 2 times 4 plus 1, 21. Yep. Good. Let's flip it over. Let's skip that one. This is the one mistake on the sheet. It should read a sub 2. A sub 1 is 0. We have a sub 2 is equal to 1. How do I find a sub 3? You plug in 3, and you get a sub 2 plus a sub 1. So what does that mean? Somebody don't use the word a, or don't use the notation a. Tell me what that means. Okay, don't use a number either. Okay, take the first number plus the second number. Take the previous term and add it to the term before that, right? Add together the two previous terms to come up with the next term, right? That's what that means. So if we do that, we get 0 plus 1, which is 1. So we have 0, 1, and 1. So a sub 4 would be 1 plus 1 is 2. And a sub 5 would be 1 plus 2 is 3. And so your sequence becomes 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. And you guys recognize that to be what? The Fibonacci sequence. Okay. We're almost done here. Let's finish up with this one, and then we'll write some rules. Oh, yeah. Yep. Order matters to me. A sub 1 is 1, a sub 2 is 2, a sub 3 is 3. How do I find a sub 4? What do I do? A sub 3. A sub 1. Okay, so I take a sub 3 plus 2 times a sub 1. So that would be 3 minus 2 times 1 is 1. A sub 5 would be a sub 4 minus 2 times a sub 2, which is 1 minus 2 times 2, and you get negative 3. Now, again, I want to be clear that we have a sequence rule. But look at this. 1, 2, 3, 1, negative 3. I mean, that's kind of difficult to try to figure out how to generate a rule for that, isn't it? Recursive definitions can be very challenging to try to find explicit formulas for, and that's one example. Let's do 4 examples where we actually try to write a rule that's recursive. Okay? I want to know a sub n is equal to, you tell me what's the next term. 17. How do you get 17? You add 2 to the previous term. So that's our rule. We add 2 to the previous term. Previous term is a sub n minus 1, and to that we add 2. And that's our rule to generate our sequence. Now, suppose somebody would not be given these terms. We would have to tell them where to start. So you have to include a sub 1 is 5, so that way you have a beginning point. Now I can generate those same values. I start with 5, and then I add 2 to get 7, I add 2 to get 9, and so on and so forth. I can generate those terms. So the deal with the recursive definition is you must be sure to give them a starting number. How about this one? How do you get the next term? Multiply by 3. So a sub n, Braden, you said? Excellent thought, but we're going to do 3 times a sub n minus 1. And we have to tell them where to start. They're going to start at a sub 1 is equal to 1. Okay? How about the next one? Yep. Just add the previous two terms, right? 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 4 is 11, so on and so forth. And what we're going to say is that you have to start with a sub 1 is equal to 1 and a sub 2 is equal to 3. So this is different than the Fibonacci sequence. I don't know. There's another set of numbers instead called the Fibonacci numbers called the Lucas numbers. I don't know which ones they are. I'd have to look that up, but these might be it. Sure, go ahead. All right, so how about the next one? What's the next term? Yeah, so the next one is 36. Very good. Congratulations. In fact, you could write the explicit formula is easy. A sub n is equal to n squared. My question is, can you write it recursively? Nothing right now. I want to know how to come up with a recursive definition here. What's the difference there? Difference there? Okay. Now. Now, watch. Watch this. So here's what you have to consider. To get the second term, you add 3. To get the third term, you add 5. To get the fourth term, you add 7. To get the fifth term, you add 9. To get the sixth term, you add 11. Isn't that you add 1 less than double that, right? You add 1 less than double that. So double 6 is 12 minus 1. Double 5 is 10 minus 1. So you take the previous term and you add to it 1 less than double the term. Now, that's one example for a recursive definition. Yes. Thank you for your efforts. Now, I'm not going to give you guys problems like that, but I just want you to understand the difference between an explicit sequence rule and a recursive rule. You can get your assignment done in class. It's super easy. It's super quick. Make it happen. Lauren, would you like to give a shout out to YouTube World on your last day of instruction?
I'm not Lauren.
I'm sorry, Tristan.
It's been real.
B. Rody, you want to say anything to YouTube Nation?
No.
Wow. Mai, any farewell? She's got stage fright. How about you, Judith?
Thanks, Mr. Guns.
Thanks, Mr. Oh, I'm going to cry. I'm going to cry. It's been real. It's been a bonding experience. Thank you. Appreciate it. Jake from State Farm would like to speak, but he's a little junior, so he doesn't get to talk right now. Maybe Jake Ware didn't ask to speak. Jake from State Farm, who's my cell phone addict, wanted to speak. Oh, now he's displacing. But Jake, life will never get better until you accept responsibility for your own actions. However many times, it's that times too many.